All right, so page 61. A circular field is set into a square with 800 meter side length. Estimate the field's area. It does give us 5 choices. 2 of them are on the next page. Again, the spacing that they do in this book is sometimes pretty ridiculous. All right, so let's estimate the area. Now we're going to talk more about area of a circle. Okay, we already know the formula. I'm going to give you that again if you didn't write it down the other day. Pi times radius squared. Remember, radius squared is not the same as times 2. Radius squared. Okay, so we have a square there, 800 meters. So what if I just asked you for the area of the square? Can you tell me what it is?
Look at the screen. Good job,
Who's that? Whatever. You can still follow along in your book until my screen doesn't get hijacked. I'm guessing somebody just did the same thing that I was talking about.
It's probably Mrs. Manlove.
That's fine. Whatever. I can handle it. Area of the square. Kellen.
I don't know.
Area of the square.
I thought I did, but I didn't.
We don't know how to get an area of a square? Yeah, well, it's 800 times 800, so that should be super easy. 8 times 8 with 4 zeros on it? Yes. 64 with 4 zeros. 640,000. Now, is our circle going to be more or less than that? Okay, so which one, looking at the options, A, B, C, D, E, is going to be less than 640,000, but yet be probably pretty close because the circle pretty much fills up majority of that square? C. Yeah, absolutely. C is correct.
Denied.
Again, when it says estimate, I didn't actually have to take pi r squared. Could I have taken 800? Actually, it's not 800. What's the radius of this circle? 400. Could I have taken 400 times pi? Yeah, but it's not asking me for an exact answer. It said estimate. All right, question 2. Boston, would you read the directions there, please?
The teacher will give you a circular object, a marker, and 2 pieces of paper from of different colors.
Okay, continue.
Follow these instructions to create a visible display.
Okay. Yep.
Using a thick marker, trace your circle in 2 separate places on the same piece of paper.
Okay.
Cut out both circles, cutting around the marker line.
Okay.
Fold and cut one of the circles in fours.
Okay.
Arrange the fours so that straight sides are next to each other, but curved edges are alternately on top and bottom. Pause here so your teacher can review your work.
All right, so that's what we're going to do. So I got a circle here. Okay, I already cut it out. It said fold it into fourths. So if I fold it in half, is that good enough? What do I got to do then? Fold in half again, right? Pretty simple. I should do it here so you can see it. Is that fourths? All right. Did you say to cut it out? Yep, okay.
Arrange the fours so that sides are next to each other.
All right. So I want you to draw this. Kind of what it looks like as I lay it out here. So I'd like you to kind of sketch this by number 4 there, since you can't do this on your own. Circle is alternating top and bottom. Okay, so I just kind of want you to sketch what that looks like. Then we're going to do what Boston mentioned into eighths and see how that changes the shape. Now, before I go too far, remember what this looked like. So if you look at the top and the bottom of this shape, what part of the original circle is this? Is this length? Where did that come from my original circle? That's the circumference, right? Because the outside edges determine how long this is. So this represents the circumference right now. So if you want to draw an arrow and show that's the circumference. How about this? What part of the circle is this, representing now our height? That is our radius. This is our radius. So our length is our circumference. Our height came from the radius. So now I'm going to do eighths. Maverick, so I got to cut these all what? So I got to cut them all 8 times?
No.
So I got to cut them on half? Yes. Do you think this is going to look exactly the same? How's it going to look different? More pieces, but how's that shape going to be different? Longer? Did I change the circumference of the circle? I didn't change the circumference of the circle.
There's going to be more.
It's gonna be more like that.
Like the Disney Channel.
Like Disney Channel. And Mandalorian. Mandalorian.
Looks like teeth.
All right, draw that one.
No.
All right, everybody have that? I'm going to go back to the book then. And I want to look at the questions on top of page 1. How do the areas of the two shapes compare? Okay, did the area of the circle change?
No.
So then the area should be, it should be equal. Yeah, number 1 should be, they are equal. They are equal. I'm just going to kind of show you a picture here. They did it 3 times. Okay. The areas are not changing. But looking at that, now let's answer number 2. What polygon does a shape made of the circle pieces most resemble? So as we go down, what is it looking more and more like? That means this whole thing. A rectangle. It's getting closer and closer to a rectangle. See how the curves are starting to disappear on the ends? It's looking more and more like a rectangle. Write that down for number 2. Okay, you could say parallelogram as well. I would accept that. It's certainly looking like that. And how would you find the area of that? How would you find the area of any of those, whether it's a parallelogram or rectangle? Jonas?
Just find the area of the circle.
Okay, you could find the area of circle. Let's talk about these shapes here, though. How do you find the area of a parallelogram? Base times height. Yes, base times height. All right, question 3. Imagine a circle made up of rings that can bend but not stretch. What polygon does a new shape resemble? So if you just pulled this ring apart, what shape does that resemble? A triangle, yes, a triangle. Write that down. Question 2. How does the area compare? How would the area of the circle compare to the area of the triangle? It should be the same, right? Nothing disappeared. So for number 2, they should be the same. Number 3, how can you find the area of the polygon? Boston? Area of a triangle is base times height divided by 2, or 1/2 the base times the height. That's what you should have for number 3. Either one is fine. Base times height divided by 2, or 1/2 the base times the height. Question 4, show in detail the steps you can find to find the polygon's area in terms of the circle's measurements. Show what you're thinking and then organize it. All right, so you stay on this page. I'm gonna go back so you can look at this at the same time. So the base, you see the base of the circle here? What color is that? Dark green. What does the dark green represent on the original circle? Circumference, right? What's the formula for circumference? Diameter times pi. So I'm going to change that to circumference. And you just write these steps down. And I'm going to change it to diameter times pi. I also want to look at the height. Do you see the height of the triangle here? Green, blue, orange, green, blue, red. What does that represent on our original circle? The radius. So I'm going to change that to radius. Now, I want to ask you what half the diameter is. Half the diameter is the radius. Notice anything? Yes? Yes, it's radius squared times pi. Does that look familiar? That's basically a proof of why the circle formula is the way it is. So we compared a circle dimensions, made it into a triangle, and we proved using a triangle why the circle formula works. So all that is showing you why that is true. So anytime you see a problem like that, the steps will always be the same. So if you have that in your notes, that'll be a good thing to reference if you see that question again. All right, final question. Question 4. Elena wants to tile the top of a circular table. You know the diameter is 28. What is its area? Well, using the formula now, why don't you see if you can get that? A hint. What's your radius? 14. So your first step has got to be what? Square 14. Not 14 times 2. 14 times 14. I'm going to give you a little start. You can check it up here in about 30 seconds. 14 times 14 will be first, and then obviously times pi. Okay, be careful, make sure everything's lining up nice. All right, hopefully you're close. Where's my decimal go, Kaylee?
Between the 5 and the 4
Okay, and do I need a label on there?
inches.
Yep, inches squared because it's area. And if you did not get it, make sure your numbers here going across are correct. If you have a missing number here or something's not right, you multiplied wrong. If those are all right and you have an incorrect answer, you added wrong. All right, now, you want to know how many boxes of tile you need for that table? It says the boxes come in 20 square tiles, and the tiles are 2 inches by 2 inches. So what is the area of one tile? 4, right? And how many boxes do I have? Or how many come in a box, excuse me? So how much area can I cover with one box? 20 boxes times 4. 20 tiles times 4, not boxes. 20 times 4 is 80. So I got to know how many boxes I need to cover my table. Well, you can guess and check. Is 1 box enough? 2 boxes? I could keep going, or I could just divide it. 615 divided by 80. Give me a number. How many times will 80 go into that? 7? And then it's going to keep going, right? 7 point something. So how many boxes, if I'm going to go buy tile, how many boxes do I need to get?
Around 7,
8. 7 boxes won't be enough because it doesn't come out equal. I can't go saw a box in half or open it up and just take a couple tiles. Right? So my options are to buy 7 boxes or 8. 7 boxes might be enough if you account for the grout in between your tiles or whatever. But I'm going to go with 8 boxes. I don't want to run short. All right, bottom of page 64. Reminder of the circumference formula. Again, I don't like the 2 pi r. I like diameter times pi better. But that's another option. Diameter times pi. Area is on the next page. Pi r squared. And your homework assignment. Page 66 and 67. Be careful. Is it asking for circumference or area? Because now you're going to have to figure out which formula to use. Circumference or area. All right, so 66 and 67.